Hello friends, I am Anil Bhagat and I am going to deliver the unit number 4. So title is electronic instrument. So the topic included in unit number 4 are DMM, then second function generator, CRO, DSO, power scope, then the auto transformer. So let's start. The first topic of your in number 4 is DMM. DMM stands for digital multimeter. So using this DMM you can measure DC voltage, you can measure AC voltage, you can measure DC current, you can measure AC current, and also you can measure resistance or resistance of any device in a digital form. So this is general block diagram of DMM. So you can draw very carefully. So there are two input lead, so acts as a text probe, so available at the input side. So just I will show you the input terminal. So this is first input and this is second input, so we mark as a 1 and 2. So here the red is indicated that the 1 and 2 is indicated that the black. So in between the actual block diagram and this probe, the one range selector switch is available. So functional selector switch, that means so you can measure the number of functions and you can choose that number of function using selector switch. Suppose if we measure the unknown DC voltage, then your switch already shows in this way. That means the switch is already connected DC voltage. That means your input applied to the input is equal to your DC voltage. Suppose you measure the DC voltage at that time, your switch available on your DC blocks. Suppose if you take the example, DC input is available here, that is unknown voltage to be measured. So now then the DC voltage coming to here. So what is the function of DC voltage? That is this block. So DC voltage attenuator, you know that attenuator is nothing but the decreasing the amplitude, that means decreasing the voltage. Suppose your voltage is high, at that time the DC voltage is very important to take the DC voltage as it is, but now it decreases, and then this voltage applied to the ADC. So what is full form of ADC? ADC is nothing but the analog to digital converter. So it convert the incoming signal into digital form in a binary form in general, and the counter understand the binary bits and then shows on the display. So this is the function of the DC voltage measurement. So these are the flow, that means DC voltage measure in this way. So second measurement is the AC voltage. So how to measure the AC voltage? So now here the AC voltage, that means this waveform you apply to these two terminal, that is positive and negative, that means 1 and 2. So now then my switch going to this way, that means I select the range, this range present on the AC voltage, my arrow present on the AC voltage. So the function of rectifier and attenuator, so rectifier convert AC into DC and attenuator decrease the voltage, and now then your signal coming to here, the ADC once again convert the analog to digital, that means your signal available in this form 0010 form. So counter counting the actual values, and now then the counter shows the numbers on the display, and that is the simple operation of AC voltage measurement. The third measurement, so which is nothing but the DC current measurement. So unknown current supplied through this wire. So now then you know that the current is of two types, AC current, DC current, and your switch is going to these directions. So current to voltage converter, because voltage always required to the ADC. So current to voltage converter, that means current flowing to the some of the resistor bank, and this resistor is always develop the voltage across it, and now we collect the voltage and this voltage supply they apply to the ADC. ADC again give the output in this form 0010 form, and the counter counting the state, and this state displayed on the display. Then the next measurement, which is very common measurement, is register measurement system. So register meter. So now this register meter is okay, the register R, that is measure in ohm. So now your switch is going to this direction. You select the switch put condition to this unit. So resistance to voltage converter block is play an important role. So resistance, unknown resistance going to the some resistor divider. For example, you can use the Western bridge, that means unknown resistor, the bridge is balanced, the output is 0, and bridge is unbalanced, the output is directly proportional to that resistor. That means voltage is our output, here voltage is output, voltage is output, is a voltage is output. So now you require the 5 volt in general to the ADC input. So 5 is a reference voltage and converted into the, so maybe 4 bit, or here as per the diagram show that the 4 wires output, that means the 4 bits always acts the output. The counter counting the actual number of states and displayed on the display. This is the operation of register, and the informations given here. The multimeter, as the name indicate, that the use the actual measuring the multiple quantities such as AC, DC. Already told you, AC voltage, DC voltage, AC current, DC current, and register also used to continuity testing. So already used in a practical sessions. So DC voltmeter, resistance potentiometer divider, circuit common used to alternate that 16. So now here is a in general operation. The second important, the instrument is function generator. So this generator generate the 3 basic waveform. So waveforms are sine wave, that is sine wave, then square wave, and triangular wave. So these 3 waveforms generated by the generator without any input. So here there are some of the controls available on the generator: amplitude control, frequency control, and duty control. So the output available here, when you switch on the power supply, the functions, that means you can select the particular waveform by using the button. So you press the button, the waveform will be selected at the output. So here the block diagram of this is in general diagram. First speaker shows that the in general diagram or block of function generator. So function generator basic definition is generator generate the waveform sine wave, square wave, or triangular wave with a frequency and with amplitude, and you can adjust the amplitude or frequency with the help of the button. The buttons are always called as the control. That means you can adjust the amplitude using amplitude control, you can adjust the frequency using frequency control, you can adjust the duty cycle using duty control. That is nothing but the buttons. So now you know that the in general diagram present in this. So there are 4 blocks: integrator, Smith trigger, and sine wave converter, and attenuator. So now here the integrator without input, that means here the frequency range, the output of integrator is triangular wave, the output frequency control the actual waveform, Smith trigger generate the square type waveform, and sine converter, that means triangular to sine signal converter by sine converter. Attenuator, so attenuator is always used to decrease the waveform amplitude, that means which want. So integrator require the inputs, but the inputs is in the form of the square waveform, that means the square. So first block of this, so first important block of this is Smith trigger. Smith trigger generate the square type output. Square type output going to the integrator. You know that square input to the triangular output is a basic operation of integrator, and on this triangular to sine is nothing but the sine wave converter. So this is in general operation of the function generator. So I just read the important points. So function generator is an electronics equipment that generate the different types of electrical waveform: sine, square, triangular, and ramp over a wide range of frequency. The output voltage and output frequency for each waveform can be varied using rotary switch. That means there are three rotary switch: amplitude, frequency, and duty cycle. The indicator is used to generate the triangular waveform, and output of indicator is given to the Smith trigger as well as the sine wave converter. Smith trigger block is used to generate the square waveform. Sine wave converter is wave shaping circuit using diodes which convert triangular wave to sine wave. Attenuator provide the output voltage control in step as well as the fine control. So minimum output frequency range is 20 Hz to 20 kHz. Function generator are used in a laboratory for testing purpose. So here the function generator and the DMM I have explained well in this slide. Thank you.